All right, next up we're going to talk about literal equations. All a literal equation is it's an equation with multiple variables. Okay? If you think about what do you know that has multiple variables in it? Well, usually what these are going to be formulas. Yeah. And the whole point of literal equations is to rearrange and isolate different variables. So if you have a formula for, maybe pressure or something, or area, and a lot of times you're trying to find the area. So like area of a circle, A equals pi r squared. So a lot of times you know the radius and you're trying to find the area, so it makes sense to have the formula solved for A. But what if you know the area and you want to find the radius? Well, if you have a problem like that, you might want to rearrange your formula so you know where to plug A in, and then it'll tell you what R is. So it's important to be able to rearrange different variables in formulas and in just normal equations as well, because a lot of our equations are going to have x's and y's, and sometimes we'll want to solve for x and sometimes we'll have to solve for y. So being able to rearrange formulas is an important skill. One thing to note on all of these is your answer. So we've been solving equations and all of our answers have been x equals a number. Well, the answers to a linear equation is just going to be a different equation. Okay? Answers will not be numbers. Okay. Now, there might be numbers involved. A lot of formulas have numbers already built in. So there's going to be numbers, but there's also going to be other variables. So again, we're just rearranging equations. It's actually a little easier because you don't have to solve for x. You're just moving things over to different sides. All right, so our first example is the circumference formula. C circumference equals 2 pi r, okay, r being the radius. Now for all of these, it's going to have to tell you, the problem will tell you what variable to solve for. So in this case, C equals 2 pi r for r. So we're going to be solving for r. All right, first thing we'll have to do is we'll have to identify where r is. Okay. And then we're going to have to figure out what can we do to get that r by itself. Well, if we need to get rid of, we have the r over here, and we need to get rid of the 2 pi. Okay. Now 2 pi is just a number. 2 is a number, pi is a number. If you need to get rid of a number that's in front of a variable, directly in front of a variable, you would divide. Okay. So we can just divide both sides by 2 pi. Okay. 2 pi divided by 2 pi, again, that's just a number divided by number. Anything divided by itself is 1, so it eliminates. So we're left with C over 2 pi equals R. Or if you prefer, you could rewrite it R equals C over 2 pi. Okay. And that's it. All we're doing is rearranging it. We've got R by itself. Now we know if we know the circumference of a circle, we could automatically find the radius. Versus in the original problem, if we knew the radius, we could automatically find the circumference. Okay. Again, all it is, and then you just leave it in that form. And we're just using the rules of math. We know how to rearrange things. We know how to switch sides. We're just using those rules to rearrange formulas. All right, this next one. We got k minus 2 over 5 equals 11j. We're going to solve for k. Okay. All right, well, again, identify where k is. K is up top. It's on top of this fraction. Okay. So we're going to go piece by piece until we get k by itself. It's the same thing as if there was x up there, except now we're not going to have, we're not going to figure out what k equals as a number. We're going to figure out what k equals in terms of the rest of the formula. Okay. So like always, if we have a top of a fraction or a bottom, if we need to get to the top of a fraction, we're going to have to knock out the bottom of the fraction first. Okay. So we'll multiply both sides by 5. That's going to drop down the k minus 2. And on the right side, 11j times 55. You're allowed to multiply terms that aren't like terms. Okay, you can multiply 5 times 11j. You would just multiply the numbers together. 11 times 5 is 55. And then j just hangs out. Okay, not done yet. We're still looking to get k by itself. It's k minus 2. We're trying to get rid of, we got to get rid of that minus 2. So we're going to do plus 2. Now the plus 2 and the 55j, those can't go together. You could only multiply anything you want, but remember, to add and subtract, you have to have like terms, and these don't have like terms. 55j has a variable j, exponent 1, and 2 is just a constant. There's no j there, so we can't combine them. But we are at our answer, or as far as we could go. We have k by itself on the left side, and it equals 55j plus 2. All right, so again, just rearranging things. K is by itself, k equals 55j plus 2. There are some shortcuts we could take when we're doing these. For example, it's often easy to take advantage of parentheses and multiplications by moving multiple pieces at once. Okay. Remember, we could rearrange multiplication problems, we could rearrange addition and subtraction problems, and remember that grouping symbols are always grouped together. So a lot of times you can move more than one piece at the same time. For example, this problem, A equals PRT. Okay, so this is an interest formula that we're going to use later in the year. It's a simple interest formula. And we're trying to solve for R. Okay, so again, identify where R is. Okay. R is in the middle there. It's surrounded by a P and a T. Now the operation that's happening, remember, PRT means P times R times T. Okay, so those are multiplications. Okay. So if we need to get P by itself, or rather, if we want to get R by itself, okay, and it's currently being multiplied by P and it's being multiplied by T, we would just reverse those with a division. Okay, and we could do that all at once. We could divide the entire right side by P times T. Okay, P over P crosses out, T over T crosses out. Now again, whatever we do to the right side, we have to do to the right side. So we're going to divide the left side by PT. Okay. So now R is by itself, and it equals, well, whatever's left over on the other side, which is A over P times T. Again, just leave it like that. Once you have R by itself, it's not going to equal a number. It's just a different formula. What about the second one? H equals AB plus R. And we're solving for R. Okay. On the right side here, there's two separate terms. Remember, terms are separated by addition and subtraction. R is its own term. AB is its own term. Okay. We need R by itself. We need to get rid of the AB. We could do that again all at once, all in one turn. If you need to get rid of AB, if you need to get rid of an entire term, we just switch it, move it to the other side through subtraction. We could subtract AB. AB minus AB is 0. Okay, whatever A and B represent, it's going to be 0. So we also have to subtract it to the left side. So on the left side we have H minus AB. Those aren't like terms. We can't combine them. We can't simplify that. We're just going to leave it as H minus AB equals R. Okay, R is solved for. Now again, a lot of times people like the variable on the left. So I could rewrite it, just symmetric property, just flip them around. R equals H minus AB. Okay. So you can move entire terms at once. You can move multiple multiplications at once. Okay. And the last scenario is you can move an entire grouping at once. Okay. So on this one we have 28 equals T times R plus 4, the quantity R plus 4. R plus 4 is in parentheses. That is always going to be grouped together. So if we need T by itself, and remember that it's T times the quantity R plus 4, we need to get rid of the R plus 4, the times R plus 4, so we can just divide by R plus 4 on both sides. On the right side, R plus 4, the quantity, divided by the quantity R plus 4, those go away. On the left side, you have 28 over R plus 4. And on the right side, all you have left is T, which is all we want. Now we'll talk about this more later, but one thing you can't do is you can't do 28 divided by 4 is 7. Okay. The denominators don't work like that. You have to have just one individual term in the denominator if you want to divide. So just leave it like that, 28 over R plus 4. You could put R plus 4 in parentheses if you want, but again, it's implied because it's on the bottom of that grouping symbol, the fraction grouping symbol. Okay. Now this problem's an interesting one because, well, we were solving for t in this problem. So we could move that whole r plus 4 over. But what if we were solving for r? If you're solving for r, that you have more than one option. Okay. So if you're just looking at this problem, if we were in live class and I asked, how would you solve this? What a lot of people would do, and this is fine, again, it doesn't matter, there's no better way, but there are two ways to do this. A lot of people would say distribute the t. Okay, again, which is fine. We know that if there's something out front of parentheses, you can multiply everything in the parentheses by whatever's out front. So a lot of people would say distribute the t. Okay, so let's do that. 28 still on the left. On the right side, you multiply everything in parentheses by t. So t times r is, we'll just say rt, alphabetical order. And then t times 4 is 4t. Okay. Now remember, we're solving for r. Okay. But we distributed, so we're kind of almost going backwards, making it harder. R was already by itself, and now it's not by itself. But that's okay, we're still going to get to the same answer. We're still going to get to the same point here. Okay. So we distributed t, which is fine. We're still trying to get r by itself. Okay. We have two separate terms on the right side, and one of the terms doesn't have an r. So we're just going to get rid of that entire term. We're just going to subtract 4t over. Okay. From the right side to the left side. 28 minus 4t, you can't simplify that. They're not like terms. So we're just going to leave it as 28 minus 4t equals, on the right side we still have the term rt. Okay. And we're still trying to get r by itself. Now remember, rt means r times t. So if we need to get rid of the times t part, we're going to divide by t. Okay. You want to divide the entire left side by t. Okay. So we now have t by itself, or we now have r by itself. So r equals, again, I'm just going to flip it around, 28 minus 4t divided by t. Okay, that's right. There's a different way to do that. Instead of distributing, okay, because again, we're trying to get r by itself, and it's currently by itself, however, it's inside parentheses, so, we can't really get to it right away. What we could do instead of distributing, we could just divide by t right away. Okay, because remember, it's t times r plus 4. We need to get rid of the t. It's on the outside. We always start on the outside and then work your way in towards that variable. So we could divide by t right away in the first step. Okay, that leaves me with 28 divided by t equals r plus 4. We don't need the parentheses anymore because they're the only things on that side. So now, r is by itself, but it's being added, there's that plus 4. So all we have to do is get rid of that plus 4. We'll do that with a minus 4. 4 minus 4 goes away. Whatever we do to the left, we have to do to, or whatever we do, in this case, whatever we do to the right, we have to do to the left. And now you have 28 over t on the left minus 4 equals r by itself. This is also right. Okay. Now these two don't look the same, but they are equal. So both of these answers are right. They do represent the exact same thing. One's just in a different form. And we'll talk more about that later and why that's the same. I might as well say it. Really, we could rewrite here. I'll put it off to the side. Really, we could rewrite this one as 28 divided by t. When you have multiple terms on top and one term on the bottom, you just take each term on top and divide it individually by the bottom. So you can do 28 divided by t separate, then minus 4t divided by t. Okay, and you'll notice those t's will cancel out here and here. And you're just left with 28t minus 4, which is the same thing as above. So those are all the same. They all mean the same thing. Okay. Whether you want to distribute and then solve, or if you want to divide right away and then solve, that's up to you. It's your user choice. Okay, the last thing that's going to help us out is the distributive property. Okay. Remember what the distributive property states. The distributive property states that if you have A times B plus C, you could rewrite that by multiplying and distribute the A to everything in the parentheses. So you could rewrite that as AB, A times B, plus A times C. Okay. We usually go forward in distributive property. We usually go from this form to that form. However, the distributive property works the other way too. We could go from something like this, AB plus AC, and go backwards. Okay, and notice that we're kind of taking out the A value. Okay, if you're in this form and both terms have an A value, you can pull it out to the front, and then whatever's left over stays in parentheses. Okay. So we're going to use that property in kind of the opposite way that we normally would. So on this problem, we have qx minus 2x equals 7, and we're going to solve for x. Now the problem with this one is there's two x's. Okay, so which one do we solve for? Okay. You can only solve for one x. You don't want to have x equal something with another x in it. Okay, you only want one x in your formula. So we're going to use the distributive property. Okay. We noticed that both of these terms have an x in it. Okay. So what we can do is we can kind of pull those x values out using the distributive property. So we pull out the x, well, what's left over? Okay. You're left with a q minus 2. Okay. Why does that work? Well, again, if you go forward now, if you were to distribute the x, you'd have x times q, qx, and x times negative 2, negative 2x. So it'd be the same thing. It's the same thing written in different forms. All right, well, now we only have one occurrence of x, and it's currently being multiplied by q minus 2. Okay, so x times q minus 2. And like the ones above, we could just divide by the quantity q minus 2. Okay. That crosses out, and we're left with 1x is equal to 7 over q minus 2. All right, and then just one more. 2m minus t equals xm plus 5. Solve for m. So get m by itself. Now again, same as the last one. There's two m's here. And unlike the last one, this one, they're on separate sides. They're on different sides of the equal sign. So we always want to gather our variables together. If you're solving for x in a problem, you get all your x's on one side. In this case, we're solving for m, so we got to get all of our m's on one side. So what we're going to do is we're going to, any term with an m, I'm going to move to the left side. Any term that doesn't have an m is going to the right side. So first up, let's move our m term. We have an xm on the right, so I'm going to subtract the entire term. Again, we could do that. Subtract the entire term over to the left. Okay, that goes away. This minus t doesn't have an m, so I need to move it to the other side. All right, so now what do I have? On the left side, I have 2m minus xm. We can't combine those because we don't know what x is. On the right side, we have 5 plus t. Again, we can't combine those because they're not like terms. So now we're going to use that kind of backwards distributive property. We're going to take these m's, because both terms have an m, and we're going to pull it out. So the m goes out front, and whatever's left over goes in the parentheses. In this case, 2 minus x. And what does it equal? It equals 5 plus t. Now we can get this m by itself, because it's m times 2 minus x. We'll divide the 2 minus x by 2 minus x on both sides. That goes away. And we finally have m by itself. M is equal to 5 plus t over 2 minus x. All right, and those are literal equations. We're just rearranging formulas. We're not solving. We're not figuring out what each variable is. We're just rewriting formulas using all the properties and all the tools that we know how to use already.